Okay, let us solve these questions. So we have M1 here from state 0, and it will hit M2. Remember, at the state 0, it is unrest. It means that the velocity of M1 is 0. So if this is OA bar, this length is OA bar cosine 60. Therefore, this length, blue dashed line, is OA minus OA cosine 60. Actually, OA bar. So we will find it out, which will be 0.4. And from stage 0 to 1, we say M1GH0 plus M1VS squared 0 over 2. So which one is the lowest position? 0 or 1? State 0 or state 1? Obviously this one. So H1 will be 0. What about H0? H0 is delta H, which is 0.4. So we will just put M1, or actually you don't need to because M1 will be cancelled somehow. And yeah, you don't need to. So we have G, which is 9.81, H0 is 0.4, and this V0 is 0, so this part will be 0, and MGH1 will be 0. Again, half M1 V squared at state 1. Okay, and remember, M will be cancelled from both sides. So V1 will be 2 times G times delta H, root square of radical, root square of 2 times G delta H. Okay, a lot of people memorize this formula when they have a pendulum. They know that when it reaches at this point, how much is the velocity. Well, now from the state 2 to 3, what will happen? We have this M1 hit M2. What is the velocity of M2? It is 0 at the beginning, okay? So velocity of M2 is 0. What about the velocity of V1? We have already obtained 2.8, blah, blah, blah. And here we put M1. So, and it will be M1 V prime 1 plus M2 V prime 2. And we have another formula for inelastic collisions. We have the E coefficient, which is 0.7. And we have this formula for inelastic collision. V prime 2 minus V prime 1. Prime means after contact, after impact actually, over V1 minus V2. Okay, so V2 is 0, V1 is this amount, and we have two equations and two unknowns. We can easily get V prime and V prime 1, V prime 2. And after that, M2 goes to the left side and it will press the spring. It will apply forces to the spring. So now we need to use the kinetic energy, the work energy equation that I gave you before. Yeah, this one's. So we need to use this formula. We don't have any MGHB because it will be 0 for both sides. We don't have any tension. This part will be 0. We just use this, this, this one, and that one. Okay, what about the velocity at the end? So the maximum compression happens when it will the velocity of the m2 will be 0, because if it is not 0, it can go further, yeah? So the velocity of m2 will be 0. It means the velocity on the state of 4. And what about the spring? The potential energy, 1 over 2k delta x, or delta L, sorry, or delta, the Greek letter, squared, okay? This is exactly LB minus L0. Let's show this by delta here. And B4, actually, from state 2, which is the after impact, we need to put V prime 2, half M2 V prime 2 squared, actually. We have everything. We will find delta, which is this number, 52.2. Again, I will explain. So we have this. Let us see what we have. This is the main formula. We don't have MGHB because if you put the datum lines, both of them have the same height, so this will be 0. We don't have any tension, this will be 0. We don't have any other forces, so this will be 0. The velocity at the end will be 0 because we want to reach the maximum compressions. Maximum what? Maximum spring compression, yep. So V, and also B4 at the beginning, actually, it was on a stretched state, so we don't have any elastic potential energy, so this term will be also 0. Remember, so this is what we need. So we have everything, okay? You have VA, M, and you have K. You will find delta.